Beer collecting on Friday, 711 up to 722. If you choose to turn in 723, that is up to you. I don't really care. Honestly, I don't really want it because that becomes a lot of papers to keep track of. So if you want to help me out, just turn in these. But if you need to, for your own organization or whatever, get rid of more papers and turn in more, that is fine. I will take them. I don't really need them, but I will take them. All right, let's make sure we talked about the other. Desmos tomorrow. Bring your Chromebooks. Please try to have them charged. I'm going to need to be leaving in about 7 minutes from now tomorrow because I have a dentist appointment, and the only time they could get me in is all these silly children are getting their teeth cleaned. I know, gosh.
Probably Valentine's Day.
Actually, I was shooting for President's Day of getting my teeth cleaned because it's a day off school. And he laughed at me. My dentist is pretty cool. And he's like, dude, you're a teacher. You know what we're booked up with. I'm like, oh, children. And he's like, yeah, dude, our day is booked with kids. So, if I didn't want to wait till March, I needed to just make it happen. So tomorrow, I got to leave here in 10-ish minutes to make it to my dentist. But then I'll be back. Also, what that means is game lunch probably can't happen tomorrow. So sorry to my game lunch people. Unless we convince another teacher to host it. Amir? Monday. So there is no school on Monday. Which, great question, Amir, because I was already thinking about sharing my calendar with you guys. So, if you want to know where we're headed right now, and obviously this is already changed, which is why I have two different copies of my calendar of what actually happened versus what I had planned, which this week is kind of speeding up. But my goal is that if we do 725 tomorrow, then on Friday, we can do a little Line Factory lab. It is more fun than I think what it sounds when I'm saying it. But then, here's the difficult part. The grade cutoff is next Wednesday. The mastery deadline is the following Wednesday. We're not quite ready for a mastery, so I'm trying to figure out what that means because I'm working really hard to try to get your test graded. My life outside of school is a little bit chaotic. My wife and I have no Valentine's Day plans because there's too much going on, right? It's a day, right? Hallmark makes a bunch of money off it being Valentine's Day today because a bunch of people are buying cards that get looked at once, but whatever. But my life is a little crazy right now, so I'm trying. But the Chapter 6 Mastery very well might be your final mastery this quarter. So when you get that back, and if you need to revise it and you revise it, that's probably it for this quarter. At least mastery work-wise. But obviously this homework this week will go on quarter 3, but then next week's homework is probably going to be quarter 4 because grade cutoff is Wednesday. And then our mastery will be somewhere down here. But then also, if you look at March, easier if I show you March from Math 7 because I've already written more stuff on this one. Guys, March is a little crazy. Junior Achievement, Author Visit Day, Discovery Day, no school because compensation for teacher conferences, 2 regular weeks, and then spring break. Guys, we are closer to the end of the year than what you realize. We're also closer to spring break than what I think you realize. So, keep up that strong effort. I know you guys are working hard, but we got a 3-day weekend this weekend. We got spring break coming. Keep up that good effort. All right, let's talk lattice, points, and slope. If you are looking at the back of yesterday's handout, this is 55I. If you're otherwise, you can look up here. That's fine. But if you want to make it a bit easier for your eyes, now depending on how much you drew with markers and stuff, it might have bled through. It might be tough. Lattice points. Can anyone remind us what lattice points are? Ahmad?
When the slope goes through a whole number x and y value on the graph.
Oh, I didn't realize I can change this color. Ah! Ah!
Oh my gosh.
Someone needs to teach me how to drive. All right. So you said when the line
reaches a point where both x and y values are whole numbers.
Where we have integer, doesn't have to be whole numbers, just as a refresher of number classification. You have to be able to order that many whole pizzas for it to be a whole number. I'm currently ordering 0 pizzas. Right now, you're watching me do it. 0 is a whole number. I can order 5 whole pizzas. I cannot order -2 pizzas. What am I going to do? Call them up, say, hey, I'm bringing pizza to you. Like, what? So, lattice points are allowed to also be negative. But what Ahmad is meaning is no decimal, no fraction, like integer values.
So it can't be like 2.5.
Correct. So lattice points are at the nice values where the lines kind of make the crosshair meetings. So lattice points, I've marked a few lattice points with my red arrows there. And the one lattice point is at 3, 8. So yesterday we talked about, okay, slope is like, delta y over delta x. So turn to your neighbor and talk about, does that mean our slope here is 8 over 3? Because we know the y, we know the x. Like, is that the slope? If not, be able to talk about what is the slope or how do we find it. Take like 60 seconds. Oh, yeah, my bad. That's a 7. Gus, if you want a piece of candy after class, you can. But see how hard it is to count on graph paper sometimes? Like, the lines start to, there's a lot of lines. So then I guess I should change my 8 to a 7. And I should probably resave this for,
Next year.
no, for next class, like law 3.
Okay. Sir, you look really nice today.
Well, thank you.
Especially with the haircut.
All right, 3, 7.
Oh, wait, no.
You little hat.
Yes.
That's a really nice hat, sir.
What's your favorite color for the hair?
Your wife for like after Valentine's Day?
We got nothing planned right now.
Oh,
Sorry to disappoint you. There are more important things right now than celebrating a Hallmark holiday. That is always important. Look, as long as she's not going to watch my YouTube video at some point this afternoon, which I doubt it because she has to go be friends with Governor DeWine, because he's showing up down at the State House or at their office today, I guess, for some reason. What I am doing is on the way home stopping by Trader Joe's to get flowers. So it's not like I'm doing nothing.
Okay,
Don't
good.
think I'm doing nothing.
See, that's what you should
We just have no plan.
Okay, that's good.
All right, we need cards.
That's good. You're a good person.
Owen, is the slope here 7 over 3? Why? I mean, that's the point we have. That's the y value, the x value. Why is that not the slope?
That's the block line.
Yeah.
Because we're not past.
All good. Simon,
Skip.
glad to have you back, but I'm not surprised you needed to skip because you got some catching up to do. Ada? Sure, but this is telling me this is definitely worth us learning. No Alex today? Oh, there you are. Alex, slope, is it 7/3 here? Why? The point is 3, 7.
Because the y over what I forgot the
Y intercept?
y intercept is not 0.
If your line comes from 0, 0, sure, you can just take your y and put it over your x. But if your line does not originate at 0, 0, you cannot just take the y value over the x. This is not the slope. Delta y over delta x, that delta means change. We need to evaluate the change in x over the change in y. So from that initial y value, what actually is our change in y? It's 6,
Over.
right? Because we get to 7, but we came from 1. So here our slope would be 6 over 3. So we can still use that 3, but the change in y was not 7. The change was 6. Questions?
Wait, no, that was crazy. No questions, but like.
It's crazier. This is 55 IV on your paper. What is the slope of that line? I think I got this lattice point right, but it's 9, 10. Yeah, I think that one's 9, 10.
Just check it.
So turn to your neighbor. If you've got your paper in front of you, that might make your life easier. If not, that's fine, but you're going to have to use the screen. Man, everybody but Alex gets shuffled back in the deck.
Wait, I didn't.
I know, but all the people that passed. You're in
right.
here.
I'm glad.
Gosh, what is going on, team? Team will not stop texting. But will that be? There's water in there. Will that be impacted by water? The pencil, no. But like, what if it keeps going down? Mick, can you give me another point that we could use here to look like make our slope triangle and look at delta y, delta x? 3, 6. Yeah, sure. So if we put that point there, then we can draw our slope triangle. Now I disagree with what you just said about it's the closest to what? Ah, so Mick is looking at this.
Like it doesn't end at 0, so it would be easier to figure out from the y-intercept.
Sure, whatever's easier in your brain. Like it's your brain, not mine. So what's our change in y? 2 or 4 if I come over here. What's our change in x?
3,
Or
6.
so wait, is our slope 2/3 or is our slope 4/6?
Both. They're
Yes. Right? Porque no los dos. Why not both? 2/3 is 4/6. Now, is our slope
equivalent. No.
no? And even if I put the repeating bar over it, no. This is especially when a rational value is better as a fraction than a decimal. It's not just better, it's right versus wrong. 0.6 repeating is never as close to 2/3 as 2/3 is to 2/3. This is close, but it's never as good as this. Slope is always a fraction unless it comes out perfect. Like if your slope is 1/2, okay, you can use 0.5. They're equal. But 2/3 versus 0.6, even versus 0.6 repeating, 2/3 is better. Slope we pretty much always keep as a fraction. So check this out. This is our formal equation to how we actually find slope. And if you wanted to put this somewhere in your math notes where we have our slope section, or in on our notes page that we took yesterday, you could write this out here like we had written. But right here in your notes, we have that slope is vertical change, horizontal change. Change in y, change in x. Some textbooks rise and run. Now, you don't really have, this is nothing to memorize. This is really like nothing to memorize. Pay attention for a second, and then you'll realize, oh, well, that's really not difficult. Look up here, please. y2 minus y1. x2 minus x1. Guys, you determine what's x1, y1, what's x2, y2, and it doesn't really matter. All that matters is that you keep things in order. So if the first y that I would use is 23, then its x value is the first x that I use, and I write down 17. Then whatever other y and x, can you go away? Maybe? Okay, maybe not. So if I use 9, 13 as my other point, 13's that y, 9 is that x. But guys, you could also just come over here and draw. Would you go away, please? You could just draw this triangle. Now that's one they didn't actually draw, right? From that point that I drew the blue arrow to up to that very top point. But what's your change in y? What's 23 minus 13? 10. So this should be 10. What's your change in x? 8. Went the wrong way. And what does 10 over 8 reduce down to?
1 over.
5 over 4.
So our slope there would be 5/4. Double check that using 2 other points from up here. Like you could do that with the bottom 2 points, you could do it with the middle 2 points. You could do the first point and the final point. See if you get the same slope doing a different subtraction up here. So we did the top 2 points. Test that out with a different set of points. Did I do something wrong? Yeah, that's not 5/9, that's 5/8. It's hard to keep a straight line across the graph. This is an 8. My B, that's an 8. I think the rest of them are right. I gotta go in and change it in my other file. That is an 8, not a 9. Get it together, Hudson. So guys, these mistakes came out of the fact that I put this together this morning to pick and choose what questions we do to try to get you some homework time. Like I'm just trying to move kind of quickly, only do what we need to do. Will, what 2 points did you choose to use? Just give me colors if you want. Blue and red? Sure. So here, what is your change in y? What's your change in x?
4.
Did we get the same thing? Absolutely. No, wait a minute. What if one of your classmates says, hey, I did this point and this point, and I got 20 over 16. They're like, your slope is wrong. I got 20 over 16. Mick?
Divide it by 4.
Oh, yeah, reduce the fraction. Guys, all because somebody gets a different answer than you, does that actually mean it's different?
No.
No. Is 5 times 4 equal to 20? Yes. So, it's just a bigger slope triangle. They just looked at more of the line. So when you're doing this work with your friends, because doing homework together is beneficial, do not assume you have to have the same numbers. I mean, it would be nice if at the end we all reduce down to 5/4 as the slope, but that doesn't mean we're going to do it along the way, right? Like while we're going, somebody might have 20 over 16. I'm like, that's fine. So take a moment. This is not on your handout. Sorry. Let's compare lines A and B, and if you need to send someone up, right? Okay, we can mark a couple points, I guess.
Yeah, let's mark a couple.
So this is obviously at 12. So then, can somebody spot another lattice point? Let's test your eyes.
What about 1, 10?
So if we go all the way up to here, where is that?
24. Wait,
624.
624.
Oh, 624.
I found 420. Unless I'm still blind.
It's like there.
I'm not blind.
Like there?
Yeah.
Okay, so Claire's saying we could also use that one. Now I want to come down to line B and find a couple points from line B. 4, 4.
No, 2,
2, 8. Oh, sorry, I was going the wrong way.
I love how there are no
Ooh, 6, 0. Anything with 0 feels like it's nice. And this obviously is 0, 12. And we just said anything with 0 feels like it's nice. So what's the slope of line A? What's the slope of line B? Take a moment, make sure you and your partner agree if you've reduced it as far as it can go.
Yeah.
You guys are very welcome to say like table one. If I went up there and put it in the 90 back so you guys can see. Laurel, can you help me find the slope? I'll let you choose A or B. Sure.
Okay, so I did green and red.
Okay. So we know we're setting up like a ratio or a fraction. So Laurel did green and red.
So I got 24 minus 20 on the top. 6 minus 4 on the bottom.
So if we write out that formalized work, or we could look, if I go up, right? I got to go the same direction. That's the big thing. 4 over 2, which is 2. And in that case, you don't really need to put 2 over 1, but we know that means 2 over 1, right? So go up 2, over 1, up 2, over 1, right? All right, so B. Simon, can you help me with B?
So you would do the same, you would do 2 minus 4.
So wait, you're using the 2 blue points?
Yeah.
Can I convince you to use the points involving zeros?
Oh, sure. So you would do 12 minus 0.
So Simon is minusing this direction, 12 minus 0. You gotta do the same for the x's.
Yeah.
So 0 minus 6, negative 6. So 12 negative 6.
Which you could simplify.
Negative 2.
Well, they're the same thing, but they're going positive anything and then negative anything. Like the correlation.
What?
No, that's not the right word. Is it? It's like positive.
I was
Yeah.
just taking a moment
Direction.
to observe, and you just started out.
Oh, well, it's.
So these slopes are opposite? Question mark?
Positive or negative?
Yeah, one's positive, one. They're technically mathematically opposite,
Yeah.
but do they look like what you would like? I feel like I would expect like a 90 degree, and maybe that's just me. That I would expect the lines to be a bit like aqua.
Turn graph around.
Won't make a difference.
Like I think. Maybe like
It is not 90 degrees.
No, never mind. Like if you expand
Standing Holland to the Perry office for just a moment. Misty, Standing Holland to the Perry office.
That's pretty obvious to me. I think it's just because their slopes are just
So guys,
not one.
opposite slopes, just mathematically one positive, one negative, are gonna look different depending on what the one slope is, and then the other one's the negative slope. So if the positive slope is intense, like 3, 4, 5, like a higher number, the negative slope is also gonna be pretty intense. What I want you to start thinking about, and I'm not gonna give you the answer today, is what slopes would make perpendicular lines. And these are not perpendicular, because to be perpendicular, what angle do they have to meet at? 90, right? Perpendicular lines, like these edges are perpendicular, right? It's a 90-degree corner. What sort of slopes, and just keep it in the back of your mind as you do your slope work through practice and everything, what sort of slopes, I don't want the answer right now, especially if you already know, great, but I don't want the class to know, I just want them to think about it. What sort of slopes, get out of here, would have perpendicular lines? All right, that might have been everything. We got one more thing to do. Sorry, this is it, then homework time. So, what is the slope of line A? What is the slope of line B? What is the slope of line C? This is on your 724 practice, so if you want to see it like in front of your face, it's on your 724 practice, which is also good because now we can write this on your 724 practice. And if you're waiting for me, you could be getting a homework problem worked on. Because this is the last thing we're doing today. Vivian, can you help me with line A? This does not look like a lattice point. Oh, 0, 5? You mean like this point? Okay, so 0, 5, yeah, I agree with that. That's a lattice point. But we need another one, right?
Wait, is 2
No.
12?
Ooh, 3 what? Guys, right up here. At the end of the arrow, 312 is a lattice point. So if we draw a sloped triangle for that, what was our change in y to go from 5 to 12? 7. Change in x, meaning the slope of line A, 7/3, which also, if you try to do that division, is not a nice decimal. Nicer than some other ones. Amir, what about you? Do B or C? B. Huh. Alright, it looks pretty tough. What's the slope of line B? Line B's got a slope of 0, because there is no rise. Now be careful though, a vertical line, and this is in your math notes, what's the slope of a vertical line? It's undefined. It breaks math. Because a vertical line has a rise of infinity and a run of 0. So can you imagine setting up the math problem that? That breaks math in like multiple ways. I shouldn't be writing on the board. I'm afraid the board's just going to catch on fire. Like, it's just, you can't do it. It's impossible. And this is why I'm afraid of AI, because someone's going to be like, hey, AI, do this. And AI's going to be like, I can't do this. And it's, going to freak out. I'm not actually afraid. I'm cautious. I'm cautious about AI. Maddie, what about line C?
So I can't find a lattice. Okay, a lattice point would be.
We know like 0, 1, right? We see that.
Yeah, so then it'd be like. It would be 5, 6, 10.
So if I draw that slope triangle there,
10, -2. -2. Yeah, 10,
you're
10,
right.
-2.
That
10,
point
-2.
is 10, -2. But
Yeah.
what's that make your change? So what's your change in y? What's your change in x?
It would be.
What was the change in y?
I don't know, sir.
1,
Oh, it'd be
2.
3, 4, 3. Negative 3.
I want to make sure you're looking at the right thing. So find change in y. We're just looking over here.
Oh,
3. Change in x. 10. So sure, I guess if you really wanted to,
Negative 3 tenths.
fine.
Oh,
But it's not as good. Because negative 3 over 10 says go down 3, go right 10. Negative 0.3 says go You're not going to go 0.3 of a square. You're not. You're not gonna. Don't even lie to me and say you want to. You don't want to. Fractions are better. Guys, I didn't think this when I was your age. I've had a complete change of heart. And I'm not just gotten old and senile in my old age. I don't know what you whispered. But, like, for real, it makes doing math easier. I'm just trying to make this easier because it's already hard. This is already tough. All right, do your homework. You've got a couple minutes left still.
Since you were wondering, I whispered when you said like going down 3, you sounded like Vsauce.
I mean, I watch Vsauce sometimes. I haven't in a while because I have no time for YouTube. The only time on YouTube is music. NPR Tiny Desk. NPR Tiny Desk concerts are sweet. Although, do not go start watching them and say I said so. A lot of them have potty mouth language. I know. What? It is good music. The lyrics are not good, but the music is good. You know, like the quality of musicianship.